Hey everyone, Michael Unger here with another episode of Ask an Astronomer. And as always, we have our trusted astronomer, Marley. How's it going, Marley?
It's good. It's still warm. I'm confused, but yeah, I'll take it.
It's still warm. It is very warm and confusing. Warm and confusing is a good way to describe the weather right now. But what's the weather like on an asteroid? We certainly had an explosive experience there. What's going on there?
With DART, yeah. So on the 26th of September, the DART mission, I guess, succeeded. It did end up destroying itself and colliding with the asteroid moonlet Dimorphos. And so I wanted to talk a bit about that today because it sent back some pretty cool images after its collision. So on the left, we have the moonlet Dimorphos. This picture was taken 11 seconds before impact by DART's camera Draco, which was the only instrument on board because why put anything on it if you're just going to destroy it? And then on the right, we have its final complete image before impact, 2 seconds before DART crashed into the asteroid. It's taken from 12 kilometers away, which tells you how fast that thing was moving. And it's the asteroid, the patch is 31 meters across. So a good chunk of the surface of the asteroid, what we're looking at.
Okay, so this was pretty exciting. It was live, and we both watched it live on our computers. Maybe some of you watched it live, and it was pretty exciting because in this case we got like live video as it was approaching, and its intent was to crash into the asteroid, but crashed into an object that NASA did not know what it looked like. I thought that was very fascinating until it got close.
Yeah, we knew it was there. We could see it like from very far away. But it took, yeah, to see it this close and this much detail is very cool. We've only really done this when we've, rendezvoused with different asteroid and comets, usually like asteroid Bennu when we're like landing and taking a sample and coming
Yeah.
back, or Comet 67P when the European Space Agency landed on that comet and kind of bounced around and took some photos. But to get anything in this detail, like up until the moment of impact, like the final image, if you look it up, is just like the strip at the top, because it crashed and was destroyed as it was setting that image back. And so to get this complete of an image of a surface is very, very cool.
Yeah. So if you're out there watching it on YouTube or Facebook, let us know if you watched this live and what you thought. I also thought that this was very fascinating because as a mission, it's kind of like it takes these different timelines. So it launched and then it hits the asteroid and we get to see immediately it crash. But then we have to go and look at the data, which is going to take some time, right? Because there was these CubeSats that are kind of monitoring it, but then also ground-based telescopes were taking some pictures. Apparently, JWST tried to take a picture as well. What's their
Yeah, I sure did.
yeah? What are some of like the other data that's come out after the impact?
So a lot of so the big part we're waiting for is for DART's full mission, right? So its full mission was to hit this moonlet and knock it into a new orbit. And we won't know if that's been successful for a couple weeks or even months because it takes time for the orbit to stabilize, right? You've hit it and that's a huge amount of energy going in to the system and it needs to sort itself out. But in the meantime, as is kind of common in astronomy, when something happens and we know in advance when it's going to happen, we like to point all of our telescopes that are able to see it at this one thing. So the other data that's come in, these are images from the Hubble Space Telescope and from the James Webb Space Telescope, kind of just showing different areas of light and brightness of what's happened when it was hit. So this is the view we got. Webb tried to look at it longer and it was able to look at it for a bit longer, but Webb is only able to track things that move up to a certain speed. If it moves too fast, Webb has a hard time tracking it and holding on. And so it did lose its tracking in one of the images. So there may be an image you find where it looks like a streak of light. And that's because it wasn't really able to track it anymore. The system was moving too quickly. But we did get
Mhm.
these really cool, bright images. So these are from Hubble and Webb, respectively. And then we got this very cool animation from the Atlas South Africa telescope where you could actually see that's when the impact occurred and that light from the debris coming off of the asteroid moonlet. So it's very, very cool being able to see this actually happen from a variety of perspectives.
Yeah. So is there any data? Like I guess it's just like a wait and see. If there was any effect on the trajectory, because that was the goal of this, right? Was to not just like do it for fun, skis, to smash things into other things, but to try to alter the trajectory of this asteroid so that in the future, if there was heading our way, we could move it.
Yeah, it wasn't just for fun, even though it was very fun. It is to test to see if we can use this type of technology, this type of science, to be able to knock something off of its course if it's heading towards Earth. And so we test that on a smaller system far away that even though we've hit it, won't ever impact Earth. Like, it won't cause any problems for us. And so it's to see. We have to wait and see. That data hasn't come back yet. Again, the orbit of this asteroid needs to stabilize, as you saw in the thing. You get this huge plume of dust coming off of it, a bunch of debris coming off, and that's just the light being reflected off that debris is what the telescope is seeing. And so a lot of different things have to kind of cool down and calm down before we get a definitive answer. But luckily, they're aiming for a pretty short orbit. So the orbit of Dimorphos before was 11.9 hours, and they're aiming for 11.8 hours. So a very kind of a small change, but enough of a change that would be considered a resounding success.
Okay, interesting. So lots of more data to come out, and hopefully by the end of the year, we'll get an update. What else is going on? I know we have an SLS update as well.
We do. Oh, sorry. These are just more images of DART. So this is from Leacock, which is one of those CubeSats that's by the Italian Space Agency. This is Dimorphos. Oh, where's my little laser pointer? There's Dimorphos, and this is the debris that came off after DART hit it. So I don't know. Very cool that we can actually see. This is a different view, so you can see all of this debris off the backside of the asteroid where DART hit. But yes, we have an SLS update. So some of you may know there's a hurricane. There was a hurricane in Florida, Hurricane Ian, and that is where the SLS launches out of, Cape Canaveral in Florida. And so they had to roll back the SLS. So it's been rolled back into its vehicle assembly building where it will wait. And the closest they could do it, they were originally aiming for September 27th, and then Mother Nature intervened. And so they've now rolled it back for its safety. They have been back on the launch pad and have determined there was no damage done, no significant damage done to the launch pad from the passing of Hurricane Ian. And so they were like, oh, we could launch in October, but we should probably let our staff make sure their families are okay, because a lot of them live around the area. So the next date for the earliest they're actually looking for is no earlier than mid-November. So between November 12th and 27th is kind of where we're looking at here for the next launch of this. And again, they'll have to roll it all the way back to the launch pad, which takes a minute, takes a very long time. And then, we may still see some delays as they were having a lot of leaks beforehand. But they're taking the time to, number one, make sure their staff and their families are okay after the passing of Hurricane Ian, kind of give them a break as well. They've been really working for this since it got rolled out onto the pad. They've been having some very long days trying to get this thing launched. And so giving them a bit of a break, as well as replacing the flight termination system batteries. So that was the other thing. They were trying to get a waiver signed so that they wouldn't have to follow the United States Space Force's kind of rule where after so many days, you actually have to go back to the vehicle assembly building anyway and replace the batteries on your flight termination system, which is a system in the core stage of the rocket where, let's say, the SLS veers off course and starts heading for a city, it could terminate the launch and just explode the rocket if need be. And so they really didn't want to have to roll all the way back and delay launch and change those batteries. But then the Hurricane Ian happened anyway, and so they've just changed them anyway. So with that being done, we should be by mid-November, hopefully all good to go. But again, Mother Nature will throw you a curveball every now and again. So there is that.
Yeah, so many different kinds of ways that it's getting delayed, Mother Nature coming back. And of course, there could still be other delays as well. Each process, there's going to be more tests. It's reminding me a lot of the delays with JWST as well, where I remember like the pandemic, delayed it, and lots of other funding. And it's interesting, from our standpoint, Marley, like we work at a space center, we're connected to the Canadian Space Agency, which is heavily invested in the SLS. And, they're invested in us promoting the SLS. And of course, like launches are a big part of that. But we know that promoting launches is kind of tricky, right? Like
yes.
It's a gamble. And you can say, okay, this event is going to happen at this time, but it may not actually happen. And, from a marketing standpoint, SLS is tied to the public's perception of it because there's a lot of money tied up in the politics of this mission. but at the same time, it's got to succeed. So,
Yeah. Yeah, it would
um,
be really bad if it exploded, right?
right.
So we want to get it right the first time. There's not a huge room for error, right? So if there's a delay, it's for a good reason, right? The last thing that there's only one of these rockets built, and it's in the vehicle assembly building right now.
Yeah.
And we don't want it. We don't want anything bad to happen to it. They need it to be a success. So they will delay and call off launches, scrub launches until they know with 100% certainty or close to that they will get a success. So
Yeah. I've known so many people that had gone to Florida to watch this historic launch, even randomly, not knowing that there would be a launch. We had a staff member that was there, and because of all the delays, almost had a chance to watch the launch until the hurricane came. So this is interesting. We'll certainly be watching this, and it will be exciting when it does launch. We just have to be patient, like with all things astronomy. Astronomy is patience. You
it
get out
truly
there,
is.
you just gotta use your eyes and look up at the stars. I was out at our telescope on the weekend, and that's what I kept telling people, like those clouds, they'll pass eventually, and then we'll be able to see what we're looking at.
No, it's a good, yeah. Eventually, this thing will launch. We just have to wait, and hopefully, with the allotted time they've given themselves, they'll be able to check out all of the problems, and hopefully, it'll be good. But I do think it's good of them to give the staff a bit of a reset. They've been on this for a very long time.
Absolutely. Very well. So you've also have got some more news as well, some interesting news about a gas giant that has not been visited very much, but was a part of the decadal survey that said perhaps we should send a new flagship mission to the planet Uranus. Yes, it is pronounced Uranus. What is going
Yeah.
on with Uranus?
That's my favorite thing, kids. I'm like, okay. Yeah. So this planet, a new paper came into preprint about this planet. Very interesting. So we all know that Uranus is knocked on its side. It's a weird planet because of that. Very different from all the other ones. Its tilt is like 97 degrees. So it spins around the sun like a ball, right? Like if you were to kick a ball. And all the other planets in our solar system have tilts less than 30 degrees, right? So Uranus is the odd one out. And a big question has been why? Like, why this planet? How did it end up on its side? Considering its neighboring ice giant Neptune has a normal tilt, and it's thought that the two of them had a very similar formation history, right? They are very similar in composition, they're similar-ish in size, they're close in similarity to Jupiter and Saturn, but the two of them are different enough that they kind of they're often lumped into the same histories because the two of them have more similarities than differences. And so a thought for a very long time has been at least one giant impact occurred when it was forming, right? So the early solar system is a very violent, tumultuous place. There's lots of stuff, flying around, lots of different orbits going on. And the right collision at the right time would have enough energy to push Uranus over while it's still kind of in its protoplanetary stage, where it's still accreting that gas and stuff. And it's possible that a giant enough impact, it just never was able to tilt itself back up. It just ended up the way it was. And there's evidence to support that. We've seen plenty of large rocks moving around, impacting other planets. And Neptune does have some differences, like a different temperature and different moons with different characteristics. So there is evidence that the two planets had a very distinct conditions at some point while they were forming. They were similar and then kind of veered off to be distinct from each other. But it's kind of weakened because if there is, this big rock or rocks moving around, why didn't Neptune get hit? Why didn't Jupiter get hit? Why just Uranus? And maybe it was just unlucky. We see in the early solar system, we got hit by a Mars-sized protoplanet giving us our moon. So maybe, Uranus just got, the short straw of things and ended up getting knocked over. But this new paper in preprint for submission to the Journal of Astronomy and Astrophysics are saying that it's perhaps more to do with a lost moon of Uranus that could have given it this tilt, is what they've been looking at and what they hypothesize and what they propose. Because sheer luck or pure luck really doesn't sit well with astronomers, even though I feel like we just need to accept that, sometimes things happen and it is what it is. We don't like it. So we try to find an answer. And their idea is that there was this lost moon of Uranus. So each of the giant planets would have formed with a large collection of moons. We see these collections, Jupiter has a ton, Saturn has a ton, but these planets are still moving throughout their formation, getting closer or further from the sun, things like that. And there's a lot of, complex gravity going on in there. So we get movements and some moons being pulled away, some getting pulled in, all these different things. And so Uranus could have been born or quickly captured from like a trans-Newtonian object or something passing through a massive moon. And if the moon was large enough, it would have affected Uranus's spin. So to do this, we kind of have to look back at Earth. Earth has a tilt, right? We're tilted 23.5 degrees on our axis, but we also, that tilt precesses. So it wobbles like a top wobbles, right? It kind of goes between 23 and 24 degrees. We kind of tilt back and forth. And so Uranus would have had this as well. Over time, a tilt will precess, right? It'll wobble back and forth. And usually a moon doesn't really care or doesn't impact this at all very much. But in this paper, they show that it's possible for a moon to get locked into a pattern with the tilt, where the time necessary for this tilt to occur, for this tilt to precess, matches up with a number of orbits the moon will take around the planet. And so the gravitational force of the moon will gently tug on the planet. And if it's in kind of the right place and the moon is large enough with a large enough gravitational tilt, it'll start to pull that planet into more and more of a tilt in its axis. It'll precess and then go a bit further and a bit further and a bit further until it lands on its side, much like Uranus is now. What happens though is that while it's getting pulled, while that moon is pulling on the planet, the moon is now moving closer and closer to the planet. So what they hypothesize is that ultimately this large lost moon of Uranus would have pulled it and pulled it and pulled it until it's on its side, and then would have got absorbed by the planet, would have crashed into the planet Uranus itself, and then is now lost. We don't see it anymore. And so I don't know, that was very cool, very fun little hypothesis. I'm excited to read their paper a bit further, but it would be very interesting if that's how it ended up tilted.
Yeah, this is a classic case of astronomers trying to uncover a mystery and then revealing an even bigger mystery of a mysterious moon that is not there anymore. So then I'm getting a lot of like Planet X vibes of like, okay, there's an object out there. We don't know where it is. Now we got to start hunting for it, which then gets a lot of people really excited and then interested in this system again, and perhaps may also fuel some of the motivation to send a mission to Uranus as well, right?
Yeah, I mean, it's like the system that's so far away. It's hard to look at, it's hard to get to, but still has these mysteries about it that are worth exploring. Like, why not? Maybe there is. I don't know how else we could see evidence of this large moon unless we look at the orbits of Uranus's other moons and how maybe those have changed over time. But it's an idea that it's common enough. A moon being large enough to cause this to happen is common enough. We see some pretty big moons in our own solar system, but it's not a common enough scenario for it to happen to Neptune. That's a lot of the thing. Well, if it happened to Uranus, why didn't it happen to Neptune? It's like, well, maybe this is just our lucky break where it's, common enough to have a moon, but it's not common enough for this to happen to Neptune. So it's still, I don't know, still worth exploring and may advance some more interest in this system for sure.
Yeah, so Pride on YouTube has a couple questions. Wouldn't that also change its shape over time? So I'm guessing that the impact, would it have actually changed the shape of the world, or just tilted it, is one question. And also, My Cap Nerd, just as a follow-up to that, is it known when Uranus would have become tilted?
This would have been in the paper. They describe it as very like early on in Uranus's history. So like if it had a large enough moon, it would have only taken a few 100 million years for it to pull the tilt over 80 degrees and for it to disappear, like collide with Uranus and disappear. The larger problem with that, Pride, is like, would it have changed the shape of Uranus? Is that Uranus is not only just like ice and a bit of rock, it's also a lot of gas. So it may have changed, like in early on, some of that inner structure of Uranus. If it has like a solid core or things like that, that would have been changed. But over time, as it continued to accrete the gas, it still would have formed like a roughly spherical shape. So we wouldn't see evidence of that with that gaseous envelope. And even over time, that rocky core would have redone itself into a spherical shape. So we wouldn't see that necessarily.
Okay, so and we're talking about early solar system. Just a little while ago is when this would have happened.
Yeah, early solar system, a couple of billion years ago. Yeah, but the whole process would have only taken a few 100 million years, but early on in Uranus's history. So
right. Okay. We have a big event coming up this evening. Do you have a little bit of news, a little bit of preview as to what's coming up? We've got an in-person event, the moons of Jupiter. We've got a special guest from UBC that is going to tell us about a study that was done a little while ago that discovered a whole bunch of new moons around Jupiter. So obviously we're going to be talking about the main 4 Galilean moons of Jupiter, but also some new ones. But you can also tune in live online as well. So you can go to our website and you can get a ticket to join live just for the planetarium portion. But of course, if you come in person, there's lots of fun stuff. We've got a Jupiter demo in our science theater. Plus, we're going to pull out the telescope and actually look at Jupiter. Looks like it's going to be a clear night too. So, but what kind of a preview can you set us up for tonight?
well, it's almost like I asked super nicely and they sent Juno to Europa because we've got another flyby. It actually flew by Europa September 29th, so only a few days after DART. And we got the closest look up at Europa's surface that we've seen like ever. Like this is the closest we've seen it. Which is great. And this image is not from JunoCam. This is from Juno's Stellar Reference Unit, which is like a camera that's not really meant to be a camera, if you know what I mean. Like it's not meant to take those pretty right. pictures. It's meant to help it know where it is. And so this is an image it took of Europa's surface, which is so awesome. The highest resolution photo NASA, the Juno mission has ever taken of this portion of Europa. And we can see it. We all know that Europa has, an ice surface, right? But we can really see these fracturing and cracks in much more detail than we've been able to see before, along with this very fun feature. Looks like something hit it, and it's very interesting looking anyway. And so this image covers about 150 kilometers by 200 kilometers, so a really big section. And we can see fine grooves and double ridges, which are like these pairs of parallel lines going along across the ice. And so they think that this upper image up here, as well as this interesting feature here, are linked to something from below erupting onto the surface. So something's bubbling up from underneath, essentially, which is it's very awesome. And very cool. So this is kind of a preview of what we'll talk about. Europa being a very icy world, hypothesized to have, a large liquid ocean underneath, which could potentially, lead to some life developing under there. And why Europa has been such a big focus, right? We have the Europa Clipper mission upcoming, dedicated to go study just this moon in particular, which is very, very interesting, very fun. So this is kind of what we'll be talking about a little bit about Europa, but more into the scientific reasonings behind why it's interesting and why some of the other moons of Jupiter are interesting.
Well, this is the first time that I'm seeing this image, Marley, and I can't help but think that looks like a giant footprint on the surface of Europa. For anyone that's prone to pareidolia, the tendency to see things in random objects. The Rorschach in-block test, as an example. But yes, this is going to be really fun tonight. So come on by or join us live through Zoom. Pride's got another question, I guess, going back to Uranus. So circular motions and gravity of the sun should govern a return to horizontal banding?
Banding or banning?
She said banding, but maybe she says banding.
Okay, so repeat it again, sorry.
Circular motions and gravity of the sun should govern a return to a horizontal banding.
Oh, like being the equator being horizontal. Yeah. Oh, should its motion around the sun and stuff guarantee that? I don't know how much the sun would play a role in it being horizontal with it, like its equator, like it being up and down, like north south, the way Earth is. How much the sun would play a role in that. The sun does dictate, its orbit. I don't know how much it dictates the orientation of the planets themselves. What causes it to be circular is like more localized to the planet system itself and how physics work and angular momentum works and things like that, not necessarily the sun itself. So I'm not entirely sure how to answer your question if I'm interpreting it right in the first place.
Yeah, so I think like all of the planets in our solar system do sort of like fit that ecliptic path, I guess, part of that would be like, would that also kind of like realign things over a long period of time? It's kind of how I'm interpreting it as well.
Oh, well, it's kind of like, I mean, maybe Uranus will precess back,
Yeah.
or, wobble back and forth, but precessions are typically very small. They don't like wildly move back and forth. There's usually something that keeps it in lock. Like Earth's precession is largely held in check by our moon, right? Our moon keeps it from wildly moving back and forth. And so it's possible that if there was such an impact that knocked it on its side, it was enough to push it past like that point of no return, where it is no longer possible for any forces from the sun or from the other moons to kind of pull it back up. It'd have to be something closer to influence it, because gravity is distant dependent, right? It's like over r squared, I think, r being distance. And so the further you are, the less gravity is able to influence you.
Okay, there you go, Pride. Well, that almost wraps up this edition of Ask an Astronomer. Thank you all that tuned in live here on YouTube and on Facebook and on Telesoptic. Of course, you can come into Facebook or YouTube live to ask questions. We will be back in 2 weeks. We do have some fun events coming up in the building as well. I just mentioned the event tonight, Moons of Jupiter. October the 21st, we will have a special visit from a Canadian astronaut, Joshua Kutrick, who's going to be coming. You can reserve a free ticket, or you can also upgrade it. You can do some fun stuff with us in the building. That's going to be on October the 21st in the afternoon. It's a Pro D day, so if you're in school, you'll probably have the day off. And then at the end of the month, we are going to be doing a really fun family event called The Strangest Things in the Universe. So we're going to be delving into all sorts of fun stuff, like black holes and dark matter, all sorts of weird and strange things.
Exoplanets.
Yeah,
Earth.
And maybe
Earth is so weird.
Well, maybe or maybe not go into the upside down. I don't know if you're a Stranger Things fan, Marley.
I am. I don't. The upside down is too freaky, I think. No, thank you.
All right, folks. We will see you in 2 weeks. That will be October the 20th, 2 p.m. Pacific time. We will see you all then.